Hello everyone. In the previous video, we have seen how to generate a pulse width modulated signal and what are the circuits that are used. Now, in today's video, we are going to see how to detect a pulse width modulated signal. Now, let us see the setup of pulse width modulated signal recovering a message signal. So this is the setup that we are used in order to recover our message signal from the received pulse width modulated signal. So here if you observe, this pulse width modulated signal is simultaneously sent to the RAM generator and also the synchronization pulse generator. Now what will these circuits will generate? So here the pulse generator will generate a train of pulses that are reference with our PWM signal, which is having a constant amplitude and constant width. Whereas the RAM generator will generate a RAM signal, and that too the generated RAM signal is having the height that is proportional to the width of a given PWM signal. Simply the height of RAM decides the width of PWM signal. So if the width of PWM signal is more, then the height of RAM generated is more. If the width of PWM signal is less, then the height of RAM generator will be less. So if you see how the waveform it will generate, so let us consider this is the PWM signal. So if you observe, this is the RAM signal that is generated from the RAM generator circuit. So here if you consider the first PWM pulse is having a smaller width, so that's why the height of a ramp is less, whereas the second pulse of PWM signal is having a larger width, so the height of a ramp signal is high. Simultaneously, depending on the width of a pulses, the height of a ramp signal will generate. Now these two signals are given to one simply adder circuit. Now what the adder circuit will do? This adder circuit will simply add the signals that are generated from the RAM generator circuit and the synchronization pulse generator circuit. After that, the output of an adder circuit is passed through the level shifter circuit. Here, what the level shifter will do, it simply shift the output of an adder signal. So how much shift that is used in order to get a perfect message signal, that depends on the application. But here, in order to understand easily, we are using a negative offset voltage, which means that whatever the output of an adder circuit is there, that is shifted to a negative side. Now this output of a level shifter is simply passed through a clipper circuit, which removes a part of a waveform or part of a information. So we may use a positive clipper or a negative clipper depending on the application. Now finally the clipper output is passed through a low pass filter in order to recover our original message signal that is transmitted. Okay, now let us see how the waveform is drawn. So here this is the received PWM signal we are considering. So in this we are generating a ramp signal and a synchronization pulses signal. So here the synchronization pulses simply generate a train of pulses that are having a constant amplitude and constant width. So this is the pulse generator that is generated. Now let us see here the ramp signal. So if you observe here, the width of a PWM signal will decide the height of a ramp signal. So if width is less, then the height of ramp is less, and if width is more, then the height of a ramp signal will be more. Depending on that, the ramp generator will generate a corresponding ramp signal with respect to the PWM signal. Now these two, that is the output of a ramp signal and the synchronization pulse waveform, are transmitted to an adder circuit or applied to an adder circuit. So what the adder circuit will do, it simply add two signals. Now we know how to do addition of two signals mathematically. Now this is the resultant waveform of adder circuit. Now this waveform of adder or the output of an adder is simply passed through a level shifter circuit which will shift some part of a portion. So here we are using a negative offset voltage. So this waveform will shift it to the negative side because of using a negative offset voltage. Now we know that this is the information that is present. So in order to retrieve this information, we have to remove the negative part of the portion. So in order to remove some part of a signal, we have to pass this through a clipper circuit. Now what the clipper circuit will do, it simply remove the negative portion of the circuit. So this is the respective waveform of clipper circuit. After that, this clipper output is simply passed through a low pass filter which is used in order to recover our original message signal, or else we can call it as a demodulated signal. So this is the waveform representation. Here we have to maintain that the ramp signal and synchronization pulses that are remain constant, and also an adder is also remain constant, but here the level shifter and a clipper circuits will designed according to a particular application. So depending on the application, we can use a positive or negative clipper, or a positive offset voltage level shifter circuit, or a negative offset voltage level shifter circuit. So this is the procedure how to recover our original message signal from the received PWM signal. So this is the final setup. So the level shifter and clipper circuit, if you design perfectly, then we can recover our original message signal having without noise. Thank you.